And action. All right, guys. So today we are doing 3.E, which is like the extension of chapter 3, which means this is the last topic of chapter 3. Woohoo! Almost done. Make sure you know your material. Okay, so 3.E is stretching and compressing the graphs of absolute value functions. And our objectives, shockingly, are stretching or compressing the graphs of absolute value functions. So homework is problem set 3.E posted on MathLab. The video will be linked, and yeah. So as we see in this extension, we are going to focus on another way that we can manipulate functions, and that is stretching and compressing. So we're going to jump right in with an example. So for example, graph h of x equals 2 times the absolute value of x, and g of x equals 1/2 times the absolute value of x. So we're going to start by drawing a table, x and y values. Actually, we're going to start by drawing a table, x, h of x, and g of x, so that we can distinguish between our two functions. So for some x values, I'm going to choose -2, -1, 0, 1, and 2. And then I want you guys to go ahead and figure out your h of x and g of x values and graph those two functions, h of x and g of x. As a reminder, you should be really familiar with the absolute value function and what that graph looks like, because again, that is one of our 4 OG functions, and those are the ones that we need to be very comfortable with manipulating. And so this is another way that we can manipulate, is stretching and compressing, and we're focusing on, again, doing that with absolute value functions. So I want you to go ahead and fill out this table, graph the absolute value functions, and then notice that the graph of h of x is either narrower or wider than the graph of f of x equals the absolute value of x, and then the same thing goes for g of x. So I want you guys to figure that one out on your own. And then moving on, we have kind of in general, for the absolute value function, we have the following. So the graph of f of x equals a times x minus h plus k, has the vertex at hk. So the vertex points are this h and that k. All right, so that means that we have minus h. So if we have like -4 plus 3, that means our vertex is 4, 3, not -4, 3, okay? So that's a little tricky thing because it's minus h. And so when it's minus, it's going to be a positive point. And when it's positive, it's going to be a negative point. So that's tricky. We'll be putting one of those in the warm-up just to try and trick you guys. You know how math teachers are. So it opens up if your a value, so that's right here, is greater than 0, and opens down if a is less than 0. So opening up is like this, and opening it down is like this. Okay. And then if the absolute value of a is less than 1, the graph is wider than the absolute value of x. So like say absolute value of x is here. If your absolute value of a is greater, then it's going to be a wider. And if it's narrower, then it's going to be, and then if it's greater than 1, it's going to be narrower. And so using all of that, I want you guys to go ahead and figure out these two examples as well. Again, these are kind of tricky, and I know I'm kind of throwing you into deep water, but I want you to try to go ahead and figure it out. Use your resources, use each other, use your previous homeworks, and yeah, I want you to try and figure it out. We will, as usual, go over it in the warm-up and as well in class time. So I'm looking forward to that. And yeah, happy end of chapter 3. We officially covered a whole chapter via distance learning. So go team. I'm proud of you all. And now I'm going to end the meeting.